Welcome back to the afternoon session, everybody. We're going to start the afternoon with a panel discussion. And in this panel, we've asked Ruzena Bajcsy and Janos Stepanovic to give us a little bit of a sense of both the history of CPS and the looking forward, the future directions involving, what's going on in the US, what's going on in Europe. And so Ruzena and Janos are going to lead the panel, and we've also asked John Ligaros and Data Gorboli to participate, giving us both an EU perspective as well as an industrial perspective. Okay, so we're going to start. Ruzena has a few slides that she's prepared with a little bit of the historical perspective of CPS. And then after Ruzena's slides, we're going to invite the other panelists. We'll turn down the projector and invite the other panelists up onto the stage to really start the panel. Okay?
So the first thing I found from this Maachen University, this diagram, which is really very instructive in my opinion. And I want you to understand that here is the cyber-physical system, but it's a very complicated connected graph, as you can see. And yeah, I think I did. Yeah, okay, thank you. As you can see, and you will see from Janos, and Shankar was involved in most of these things. So cybersecurity, we had a big institute here at Berkeley, multi-university. From all what I can gather, the genesis of the cyber-physical system started actually from embedded systems. Where are they? Well, somewhere here are the embedded systems. And I remember that at Berkeley, of course, Ed Lee was one of the pioneers, but there were others. At Illinois was Lou Shah, at Penn was Insap Lee, and so forth and so on. My connection to cyber-physical system and to Shankar came through these hybrid models. And I have a couple of slides on that. So the chronology I found, which is interesting, really goes back to Tesla, who is one of my countrymen, so-called, teleautomation. And then, of course, Norbert Wiener coined this word, cybernetics. Then, interestingly enough, in 1961, Charles Draper had built the first embedded system. So what I'm trying to show you folks, especially the students in this audience, that we all stand on the shoulders of others, and nothing is completely out of the air. So then Ashton, Mark Wieser, who was at Xerox PARC, coined this 88 ubiquitous computing. Then Ashton coined the 99 Internet of Things. And I was very lucky. I got to NSF when, under the Clinton administration, when Rita Colwell was the head of NSF, and the community negotiated new $150 million for computer science and information technology research money. It was completely new. You see, at NSF, typically, when the allocation comes to NSF, the director typically divides it in, quote, fair fashion to 7 or 8 directorates. And, but in this case, computer science got an extra, computer science and science, computer information science and technology got an extra $150 million, which was given to me to design a program, and that's how I started the ITR. Now, concurrently, at the same time, Shankar took the job at DARPA. And so we cahooted together. and how to design a program that we believe that really deserved extra or new support. Helen Gill was a program manager who worked for me, and she has been extremely connected to the community, and she understood where the community is heading. And so after I left, actually after both of us left, she coined this word cyber-physical systems, but the seeds were given during our time when Shankar and I were in Washington, D.C. Do you remember, Shankar? Yeah, good. All right. Okay, so the chronology of hybrid systems. So I started the GRASP Lab in 1979, and 78, 1 year before, Arvind Joshi, who was the chair of computer science at that time, started the cognitive science program. We combined these two programs and merged them into an AI center. And the reason I'm mentioning all of this is that you should really understand that while Shankar got his PhD 81, and the following 80s, he spent all his, I went through all your papers, and he spent all his 80s on robotics problems, not on control. I mean, control was part of it, but it was really robotics. Okay. Then 83, Roger Brackett established Harvard Robotics Lab, okay? And the important thing happened when this program manager at ARO started, and his name was Chandra, and who really started this 10-year program. You can see that the longevity is so critical in order to solve some hard problems. Started this 10-year program, Center for Excellence in Intelligent Control Systems and AI. And the program supported, it was, I remember, something around between $15 to $20 million. And it supported Harvard, Roger Brackett, MIT, Sanjoy Mitter. At Brown, I couldn't figure out who were the people there. At Cornell, Anil Nerod, do you remember Anil? He was a logician, actually. At UC Berkeley, Praveen Varaya and Shankar Shastri. And at UPenn, it was the two of us, Joshi and Bajcsy. And it was during this time when I really met Shankar and learned all about, what these folks. So, birth of hybrid systems, the importance of long-range funding. So, 83, Ramadaj and Vonham published their first paper. It was Ramadaj's thesis, discrete event systems. Notice, 83, Shankar's PhD was 81, okay? Subsequently, Brackett, Nerod, Mitter, Shastri all advanced the idea, which eventually turned into hybrid system. The discrete event systems were not hybrid systems. They didn't have but it combined the computer science, which had the automata theory, and differential control equations into the hybrid system. Shankar worked on robotic system, 83 on robot manipulation. Shivan Lee on task-oriented optimal grasping. So all the stuff that we do today, folks, been explored in the 80s. And that you should really remember. Okay, and because of the ARO Center, we all met twice a year. Remember those meetings? Between 86 and 96, okay, which influenced all of us as participants. I was the experimentalist, okay, but these folks were pushing theory, but I was the, and 98, Tomlin, Papas, and Shastri published a paper on so look at that. After 96, 2 years later, Tomlin, Papas, and Shastri published a paper on multi-agent hybrid system. And then Jana Košecka, I don't know if she's here, but she was the first student of mine in '94, before even Tomlin and Papas and Shastri did that in the GRASPA, first used discrete eval system as a tool. Basically, we had two mobile vehicles, and then she modeled their movement and how to collaborate so that when they avoid obstacles, they meet again. That was her PhD thesis. So I think this is probably the end of my slides, but the message I want to give, two things. One is the students here, remember, you stand on the shoulders of others. And you should read those papers because they were really very avant-garde. Number two message I want to give everybody else between age to 40 to 60, if you are called to serve in Washington, you should accept it. It's extremely important that good people get into these positions who understand the science and have a vision where the community wants to go to help them to get there. Thank you.